Okay, so the question A was asking us how much volume was heated, how much volume of air was heated per day. Well, we know the efficiency is equal to work over the input power or input energy, okay? Which is equal to work over the energy loss plus work, okay? Because the energy loss plus work is equal to the input energy. QI is the input energy, QL is the loss energy, okay? Which means that QL plus W is equal to W over E. Therefore, we have QL is equal to W over E minus W, which is W times 1 over E minus 1. And E is the efficiency here, okay? And we have QL divided by T will be equal to W over T times 1 over E minus 1. If we plug in the value, we'll have W over T is the power, which is given as 850 megawatts. And 850 megawatts is 850 times 10 to the power of 6 watts. Okay, because 1 megawatt is 10 to the power of 6 watts. And then this whole thing's times 1 over E minus 1, which is 1 over 0.38 minus 1. Because 38% was the given efficiency, and 0.38 is equal to 38%. Okay, and this will give us the energy loss per unit time will be equal to 1.387 times 10 to the power of 9 watts. Okay, and then we know almost all the energy loss was converted to heat. Therefore, QL is equal to MC delta T. M is the mass of the air, C is the specific heat of air, delta T is the changing temperature. So therefore, we can also make QL in such form, which is QL over T times T. Okay, and this is also equal to MC delta T. And if we move M to the left side and everything else on the right side, we'll have QL over T. QL over T times T over C times delta T is equal to M. Okay, and remember our goal here is to determine the volume, and volume can be expressed in such terms, which is we know the density times the volume is the mass, so rho v can be represented as M here. Okay, so rho v can just substitute for M, and we have rho v is equal to QL over T times T over C delta T. And then let's move rho to the right side. We have V is equal to QLT times T is equal to, so not equal, over, rho C delta T. Okay, and that's, now we can plug in the value. Actually, let me see, I forgot to put the denominator on here. Okay, so QL over T. Okay, so now if we plug in the value, we will have 1.387 times 10 to the power of 9 watts times, since there are 24 hours in a day and in 1 hour there are 3600 seconds, so the total seconds in a day is 24 times 3600 seconds over rho, which is given as 1.3 kilogram per meter cube. Okay, times the specific heat of the air, which is given as 1 kilojoule per kilogram times degree Celsius, which is 1000 joule. Per kilogram times degree Celsius, and then times the changing temperature, which is 7 degrees Celsius. Okay, and this will give us the volume that will be heated per day is about 1.387 317 times 10 to the power of 10 meter cube. Okay, if we convert it to kilometer cube, it's 13.17 kilometer cube. Okay, so it will be 13.17 kilometer cube of air is heated per day. Okay, and for such amount of volume of air was heated, it definitely affects the local climates. Okay, so yes, it will affect it. So for question B, you want us to determine the area. Well, since we got the volume and the thickness was given from the question, which is 180 meter, so we have the area is simply equal to V over X. V is the volume, X is the thickness, A is the area. Okay. Volume was figured out as 13.17 kilometer cube, and the thickness was given as 180 meter, which is 0.18 kilometer. Okay, and this will give us the area is about, let me see, it was about 73 kilometer square. Okay, so this is the area that will be covered for 24 hours of operation. Okay, and these are my answers for the question. Thank you.